Wildcat, so we're going to get 2. Folds, turns, and zeros. The teacher works 3 and the student works 1 and 2. Okay, so 3. Okay, so I'm going to move the work for 3 right here. So first off, x times x plus 1 becomes x squared plus 1x, and then that's times 1/2 x plus 1. Okay, at that point we're going to multiply using the box method, so 1x squared plus 1x times 1/2 x plus 1. Okay. Now 1/2 x times 1x squared is 1/2 x cubed. 1/2 x times 1x is 1/2 x squared. 1 times 1x squared is 1x squared. 1 times 1 is 1x. So this simplifies to be 1/2 x cubed, which is 1 x squared plus 1/2 x squared is 1.5 x squared plus 1x. Now, to be consistent, since we converted this to a decimal, let's go ahead and convert that to a decimal. So let's rewrite 1/2 as 0.5. All right, go ahead and finish up question number 3. All right, let's take a look at the next page. All right, go ahead and mark out that page. All right, 2.1, creating functions of higher degree. Recall that you can dilate a function vertically by multiplying the function by a constant. For example, if the function is f of x equals x, then f of x equals a times x represents a vertical dilation of the original function. What happens when you transform a function by an a value that is not a constant? Suppose the function f of x equals x plus 3 is dilated by x or x times f of x. This would mean that the y value of every point on the line y equals x plus 3 is dilated according to its corresponding x value. 1. The graph shows the function f of x equals x plus 3. Choose several points on f of x and dilate each by multiplying by the x value of the particular point. Then sketch the graph. 2 points have already been dilated. Alright, so first things first, let's go ahead and graph f of x equals x plus 3. Okay, so to do that, we're going to use Desmos. I'm going to graph f of x equals x plus 3. And then I'm going to click this little circle right here, add table, and then I need to change the values to match the table on the page. So -4, -3, -2, -1, 0, and 1. All right, let's go ahead and complete that table. All right, let's go ahead and graph those points on the graph. So -4, -1, 2, 3, 4, -1, -3, 0, -2, 1, -1, 2, 0, 3, 1, 4. All right, so this is this line right here. Go ahead and finish up this table and graph. All right, let's take a look at the next graph. Okay, so I'm gonna come over here, exit out of that, and let's do g of x equals x times x plus 3. I'm going to click right here, click on the table, and let's change the values to match the paper. So -4, -3, -2, -1, 0, and 1. All right, let's complete that table. All right, let's go ahead and graph those points. So -4, 4, negative 4, 1, 2, 3, 4, negative 3, 0, so negative 1, 2, 3, 0, negative 2, negative 2, negative 1, negative 2, 0, 0, and 1, 4. All right, go ahead and complete the table and graphs. All right, question 2. Write the equation to represent the new function g of x equals x times f of x. How did the dilation change the degree of the new function? G of x equals x times f of x equals x times x plus 3. Okay, 3. Identify the zeros of g of x. How are these related to the two linear functions x plus 3 and x? Let's not worry about that. Let's find the zeros. All right. So the zeros are this point right here. So negative 3, 0. And 0, 0. All right, go ahead and finish up that page. All right, let's take a look at the next page. All right, go ahead and mark out this page. All right, let's take a look at this page. Suppose the function h of x equals negative parentheses x plus 3 is dilated by x or x times h of x. The student works 5, 6, and 7. All right, so we'll take a moment to write down those tables. All right, and then go ahead and write down the information for 6 and 7. And then go ahead and complete those problems in Edge Elastic. All right, let's take a look at the next page. All right, go ahead and mark that page out. Go ahead and finish up your notes and have a wonderful Wildcat day.